Hello everyone, and welcome to this random Factorio video in which I'll be demonstrating a scrolling text marquee that can be built out of elements in Factorio. Here it is. Ooh, ah. So, why are we doing this, you might ask? Because we can. And because I had never actually up until now done anything with the circuit network at all, because I couldn't think of a legitimate use for it. And I guess this still doesn't count as a legitimate use because this is completely useless, but it's still fun and it's still pretty cool, and I thought it's even a little educational and kind of learn some stuff about electronics and computer science, question mark. Yeah. So I guess one other thing, the reason I haven't been doing speed runs lately is mostly because of the new patch, and there were some new features I wanted to just experiment and play around with. And one of those was achievements. So I've been in the process of building this huge mega base with the goal of making 20 million electronic circuits, which was the last of the achievements I needed to do. And maybe I should have actually been streaming some of that stuff, because making 20 million circuits is pretty hard. You have to make a pretty big base in order to do that in any reasonable amount of time. So maybe I'll show off some of that stuff in a later video. Like, we're actually in the middle of that, well, sort of on the corner of that base right now. Like, we are here. This is the scrolling text marquee, and then this is everything. But anyway, like I said, let's do that in another video and start explaining this scrolling text marquee. It's actually fairly simple compared to what you can do with the circuit network. I believe the circuit network is Turing complete, which means you could build a functioning computer out of it. So anything that you can do with computers, you can do with the circuit network in Factorio. And in fact, this is the kind of dumbed down version that just uses transport belts to make these things scroll. I'm pretty sure there's a completely electronic version where you could implement scrolling without transport belts, just purely using electronic signals. I'm not sure if I want to attempt that, but maybe some of you are, maybe somebody will, I don't know. Anyway, then you could even control the text speed and program that. Anyway, so let me just demonstrate this thing really quickly. It's displaying a message, and I can even control the color of the message. So in the new version of Factorio, you can control the color of lamps. So I can make it red, green, blue, yellow, magenta, cyan, or just white. I'll leave it on yellow because that's pretty easy to see. And of course, you can also control what the message says. So let's make it say, I don't know, Happy New Year. So you spell out Happy New Year in the outputs of these decider combinators here. Oops. Don't think, yeah, I think I did that right. Happy, and then to put a space, we just put anything that's not a letter, basically. N, E, W, Y, oh, whoops, no, I wanted that to be space. And then Y, E, A, R. And then to signal the end of the message, we actually have to put a 0. And now it should be saying Happy New Year. How cool is that? And it'll even just automatically cycle back and just say, start saying Happy New Year again. So let's break it down. How does this actually work? Starting from the, let's start with this LED display itself, or these are actually lamps. So each lamp is connected in a one-to-one fashion with one of these transport belts. So for example, this belt here is connected to this lamp. And the lamp enable condition is set to car greater than 0 and use colors. So when a car goes on that lamp, when a car goes on this belt, it causes that lamp to light up. And then, yeah, this belt is just set to read belt contents and hold read mode. So just to demonstrate this a little more clearly, let me just turn the scrolling message off for now. I think I got it. So yeah, it's not doing it. So now if I just, for example, stand on this belt here and drop a car from my inventory, you can see that that car is lighting up lamps as it moves along the belt. And if I press F to pick up the car, then it's gone. So obviously something is feeding cars onto these belts, so we'll get to that in a second, but I'll just kind of walk down where the cars go. So the cars follow this return belt all the way back into what I'm calling this printer unit here. So the printer unit is designed to basically the main element in this printer unit are these inserters here that are connected to this circuit network, and they're designed to print the image of a letter simultaneously, and they're activated using signals on this green circuit network here. So for example, so the letter A turns out is copper plate. So if I put copper plate on this belt here, it causes certain ones of these inserters to move, and it spells out the letter A. And each letter, it turns out, has a different item that represents it. So iron plate is a B, I think. And I don't know, if I put down this stone here, it might print something. Yeah, it's going to print a U. And if I put down a solid fuel, it's going to print a Y. Buy more products. Okay, so right, so how does that actually work? Well, let's take a closer look at these inserters. So each inserter here is connected again in a one-to-one fashion with these steel chests down here. So each inserter, for example, this top left inserter is connected to the top left chest, and so on. And also the inserters are connected together on this green network. And the enabled condition is set to anything greater than 1. So basically what's happening, so basically what has to happen is a signal has to be active on both the red and green networks at the same time in order to activate. So I mentioned these are connected to these chests. So you might have guessed what these chests are actually for. Data. More specifically, these chests are a form of read-only memory. They're storing the images they're storing bitmaps for the letters A through Z. So I mentioned that A is copper plate, right? So actually, like, some of these chests have copper plate in them, but some of, this one doesn't. So like the ones, excuse me, so the ones that have copper plate are spelling out the letter A. And so, right, so basically certain inserters are connected permanently to one copper plate, so to speak, which means that when a second copper plate is dropped onto here, 1 plus 1 equals 2, and each of these enabled condition and those enabled conditions go. So the only real question is now, what is controlling these pulse signals that are being sent along the green network? Obviously it's not this. This is just for demonstration. So what's sending the signals is this message reader down here. So I've turned that part off, but I can turn it back on just by putting a car down on this belt. So when the car passes along this belt, it causes yeah, sorry, brain fart right there. So basically, when it's read by the transport belt and fed into this combinator. So the combinator will activate and output a signal of W. Or when I'll just use the H as an example. So when this when the car goes here, it outputs a signal of H, which for some reason puts an H. But remember that H isn't actually represented by H. It's represented using a specific item. So that's what this little array is doing over here. This is actually the cipher. So the outputs of these are fed into the inputs of these, and I guess FGH. Yeah, H is this one. So when it receives an H, it outputs a wooden chest. Because H is this special signal. I can't obviously put H's into these boxes, so I'm using wooden chests, and the wooden chests are, yeah, and the letter H is spelled out in wooden chests over here, as discussed previously. So that's pretty much everything. That's pretty much how it works. And oh, I guess there's one last thing, which is the end of message. That one's pretty simple. So when it gets to the 0 here, 0 doesn't code for anything, except what it does do is it causes that inserter to move. So this inserter is set to 0 greater than 0, which doesn't sound like it makes any sense mathematically, but yeah, 0 is just a special signal, so it actually does make sense. When 0 is greater than 0, it causes this inserter to put another car onto the belt, and start spelling out the signal all over again. And just this chest is always going to have an excess of cars in it. So you might be wondering why I am using an object as complicated as car to do this. Couldn't I just be using like iron plates or something easier? It turns out I could be using something easier except that I have the tech upgrade for inserter stack size, meaning that if I was using iron plates, say, then each time these inserters moved, they would actually put down 3 iron plates. And if you've got 3 things, it doesn't give you a nice crisp signal, or it doesn't give you a nice crisp image. It would be fuzzy and the scrolling wouldn't look right. So I guess if you have a game in which you don't have that tech upgrade, then you could use something simpler. But with cars, cars only have a stack size of 1. You can't stack them. I think they're the only item in the game like that, other than maybe like rocket silo or something. But yeah, it means that even with the inserter upgrade, you can only ever move 1 car at a time, no matter what. And that's what I want. But God, it was annoying to make enough cars to make this actually work and be nice and big. Because, yeah, I had to put like several hundred cars into this just to make sure that the printer would never run out of ink, because there's like, 4 4 in each of these chests, and then these belts have to be full at all times, and then this, you know, and then there's plenty of cars both on the return belt and on the outgoing belt at all times. So it kind of requires a lot of cars. But that wasn't too hard to do, believe it or not, to make all those cars with this mega base, which I already have, which is capable of making 20 million circuits, among other things. But anyway, oh yeah, just one last thing. If you wanted to do this on your own, it might be easier not to use steel chests. Kind of, as I was halfway through this, I realized I could have just used constant combinators. So like, you know, you could make a 5x8 array of constant combinators, and then there would be no need for this code. You could just, you know, have them output a, you know, E. You could just have them output whatever letters you'd need to. The only problem with that is that some of these chests have more than 15 items in them, and a constant combinator only allows 15 outputs. So, but you could still fix that by just making, you know, a duplicate array of constant combinators. It wouldn't be that hard to fix, and it means you wouldn't need any of this cipher garbage over here. Yeah, another tip if you're building this on your own is that you're gonna want to just kind of set up one column of it and then use construction robots to just duplicate the columns. Because this, as you imagine, this wiring is pretty confusing to get it right. But yeah, so you should have enough information to be able to do it more or less on your own if you want to. So I guess that's it. Happy New Year, everybody. And if you liked this video, or maybe you have an idea of something you want to see in the circuit network, or created using the circuit network, or maybe you just want to see more speed runs, I don't know. Feedback might be nice. Go ahead and comment on this video, and I'll see you guys next time.